Okay, we're going to start lesson 5 of module 5 today. In this lesson, you're going to be able to graph functions. You'll know you're successful when you can create a table of values from a function and then graph that table of values. You'll also be able to determine, if you're looking at a graph, if it actually represents a function or not. We're going to go through examples, exercises. We'll do our closure, our exit ticket, and later you'll do your reflection. Let's get started. Alright, so for example 1, I'm going to read through this, and please just write down everything I write down. It shouldn't be too much of a new learning. It says, the distance that Giselle can run is a function of the amount of time she spends running. She runs 3 miles in 21 minutes. Assume she runs at a constant rate. A says write an equation in 2 variables that represents her distance run, y, as a function of the time, x, she spends running. So we're going to create an equation here. My suggestion is that you always create a table before you create your equation because it just helps you out a lot. Okay, so it says that y is the distance, so this is the distance, and x is our time. Alright, so those are my 2 columns, and then I'm going to take the initial information they gave me. It was that she runs 3 miles in 21 minutes. 21 minutes, 3 miles. Okay, I'm going to add to this table as I go through this example. Alright, we need to create an equation from that. Now looking at everything they've given me, they have not given me any additional information, so I'm not going to be putting a plus b in my equation. So remember, our equations are written in y equals mx plus b format. This is where we write in any additional information. So say she would have stopped for 5 minutes. That's where we would put that in. Okay, but we don't have that here. So we are just looking for our m, which is our constant rate. Okay, and we find m by doing y divided by x. So in this case, my y is 3. My x is 21. This is a pretty clean-cut fraction, and I'm going to reduce it right now by 3. 3 divided by 3 is 1. 21 divided by 3 is 7. And I'm going to leave it as that fraction. So the constant rate for this equation, or the slope, is 1/7. So our m is 1/7. I'm just going to fill that in my equation. So my equation is going to be written as y equals 1/7 x. Okay, I have 2 variables, my y and my x, and I have my constant rate, my m, which is 1/7. Okay, moving on to part B. It says use that equation to determine how many miles she can run in 14 minutes. So now I have 14 minutes here, and I'm trying to figure out how far can she run. What's the distance she can run? So I'm going to take that equation I wrote, y equals 1/7 x, and I'm going to multiply it by my new x, which is 14 minutes. So again, minutes is our x, because that's time. So I'm going to be changing this x to a 14. Okay, this becomes y equals 1/7 times 14 over 1. Okay, when I multiply my fractions out, 1 times 14 is 14. 7 times 1 is 7. So I get 14 over 7. If I actually do that math, 14 over 7 is the same as 14 divided by 7, which equals 2. So, how many miles can she run in 14 minutes? She can run 2 miles. Okay. The next part says, use that equation we wrote in part A, same equation as before, to determine how many miles she can run in 28 minutes. So again, 28 minutes, this is my x value. So I'm going to be adding that in to my equation wherever my x is. And I'm trying to figure out, okay, in 28 minutes, how many miles can she run? So my original equation, y equals 1/7 times x. This time I'm doing times 28, so y equals 1/7 times 28. Because I'm multiplying a fraction, I just put 28 over 1. And I'm going to multiply. 1 times 28 is 28. 7 times 1 is 7. 28 divided by, 28 over 7 is the same as 28 divided by 7, which is 4. So, in 28 minutes, she can run 4 miles. All right. Now, based on what I've done so far, I want you to try the next one on your own. This one says how many miles can she run in 7 minutes? Okay. So please do the exact same thing I did for part B and C. For part D, this time you are putting in a 7 to your equation. Okay, and we'll go over it in about 30 seconds. Tell me, how many miles can she run in 7 minutes? All right, when you set this up, 1 times 7 is 7. 1 times 7 is 7. 7 over 7 is the same as 7 divided by 7, which is 1. She can run 1 mile in 7 minutes. So none of this is new stuff. This is just a review of what we have already learned in the past. Okay, we're going to take this table and continue to use it on our next slide. All right, continuing with that same example, I've just written the table of values we made on the last slide off to the right. It says, for a given input x of the function, a time matching the output of the function y is the distance she ran in that time. Write the inputs and outputs as ordered pairs and plot them as points on a coordinate plane. So we're just going to graph these. So this is going to be 21, 3. That's going to be one of our points. 14, 2. 28, 4, and 7, 1. We're going to plot these all on our graph. So the first one is 21, 3. So we're going to go 21 for our x. So we go over to 21. It's right here. And we're going to go up to 3. Make a point. Okay, did that one. Next one, 14, 2 over 14. Up 1, 2. Did that one. Next one, over 28. Up 4. There we go. And the last one, over 7, in between 6 and 8, up 1. Okay, so I've plotted my points. What do you notice about the points that we have plotted? Well, I noticed they form a straight line. Right? Does everyone see how they form a straight line if I were to draw a line here? Let's see if I could do it with my highlighter instead. So this is linear, okay? The next question it asks me, is it discrete? So remember, discrete means each x can have only one y. So look at all of our x values down here on the bottom, on our x-axis. Is there ever a point that's on the x-axis that hits another point? That one only hits that one point. This one only hits that one point. This one only hits that one point. And that one only hits that one point. So yes, this is discrete. Each x has only one y. All right? And then the last one says, use the equation you wrote in part A to determine how many miles she can run in 36 minutes. Write your answer as an ordered pair and include the point on the graph. Is the point in a place where you expect it to be? Explained. So I want you guys to do this right now. Please tell me, figure out 36 minutes, how long or how far she's going to be able to run. Okay? So find that value for me using our equation, and then tell me, is there a place where you expect it's going to be over here? So 36 is right here. Where do you think this is going to land? I'll give you a couple minutes to do this one, okay? All right. So if you were doing this one, I would say that I expect this point to land right around here, okay? And I'm going to do the math out to check it. Our equation is y equals 1/7 times x. In this case, our x is at 36, so y equals 1/7 times 36 over 1. 1 times 36 is 36. 7 times 1 is 7. 36 over 7 is the same as 36 divided by 7. And when I do that, I get 5.142, blah, blah, blah. So I would just round it off to 5.14. Let's see if that's about where I expected it to be. So if I go over to my 5, yep, it's a little bit above the 5.14. It's exactly where I expected it to be. Okay, make sure you have this down before we move on to the next part. All right, so the next 3 questions or so, they're pretty repetitive and just get you to kind of answer what we've already identified. But basically, no matter what we plug into our equation, y equals 1/7 x, it will form a line. It's going to be linear. And it's always going to be discrete, because if we plug in a different number for x, it's going to give us a different y. Okay, we're never going to get this 2 different y values for the same amount of time. You can't say, okay, well, she ran 5 minutes and it took her, or 5 minutes she ran 3 miles, and in 6 minutes she also ran 3 miles. That doesn't make sense. So it's never going to be that. So this is a discrete function. Each x has exactly 1 y output. Okay, so that's what I wanted you to get from this example. Moving on. All right, moving into example 2, it says sketch the graph of the equation y equals x squared for positive values of x. Organize your work using the table below and then answer the questions that follow. So let's fill out this table together, and then I'm going to have you guys answer the questions that follow. So the first one, we're doing y equals x squared. For this first one, my x is 0, so y equals 0 squared. Well, what's 0 times 0? 0. Okay? For the second one, y equals 1 squared. Well, what's 1 squared? 1 times 1? 1. Okay, the next one, y equals 2 squared. Well, 2 times 2? 4. Please fill in the rest of your table and I'll reveal it in about 30 seconds. All right, check your table with mine. Here are our values, and we are going to plot these on the coordinate plane. So we're writing them as ordered pairs. So the first one is over 0, up 0. That is right here. Okay. The next one is over 1, up 1. Over 1, up 1. It's about in between the 2 and the 0. The next one is over 2, up 4. Over 2, up 4. Right there. The next one is over 3, up 9. Over 3, up 9, that's right in between 8 and 10. Next, over 4, up 16. Next one, over 5, up 25. And then the last one, over 6, up 36. Okay, so our question says, what shape does the graph of the points appear to make? So I want you to connect these dots together to form a line and tell me what shape do you think that this makes? Well, you should see that this has a curved line. So this is curved. That means it is not straight. That means it is not linear. So this is no, this is not linear. And we learned at the very beginning of our school year that if our variable has a squared or an exponent attached to it that is not a 0 or a 1, which it does in our equation, it's a 2, then it's non-linear. So this is not a straight line. This is a curved line. Okay? Moving on to the next slide. All right, this next slide kind of goes with our last one. It says, consider the function that assigns to each square of side length s units an area of a square unit. So we have our x and our y. This is saying, okay, our side length, and this is our area. Okay? It says write an equation that describes this function. So let's just say our side length of our square was 1. So imagine a square that has a side length of 1. How would we find the area? Well, we would do our length times our width. In this case, it's 1 times 1. Well, 1 times 1 is 1. All right? Well, let's do a square that has a side length of 2. Well, this time, what's our area? Well, it's going to be length times width. 2 times 2, or 2 squared. This is going to be 4. What if we had one that was 3? Our side length is 3. Our area, 3 times 3 is 9. So this is actually following the exact same pattern as our previous page. Basically, our rule here is that we're taking our x value and we're squaring it to find our y value. So y is just our x value squared. That side length squared gives us our area. So what do you think this graph is going to look like? Well, this is the exact same equation as our previous one. So I'm going to say that my graph is going to look like this, right? It's going to look like an exponential curve. And the reason being is that as I go up, it continually gets steeper and steeper and steeper and steeper. My numbers get higher and further apart. Okay, my x and my y values. All right. It says use the function you wrote in part D, which is y equals x squared, to determine the area of a square with a side length of 2.5 units. So if this is a 2.5, what is this? Well, 2.5, if I have a square, it's 2.5 on every side. To find the area, I would just do 2.5 squared, or 2.5 times 2.5. And when I do that, I get 6.25. Okay? For the area. Will it go on that graph? Yeah, it will go on this graph because it follows the same rule. So yes, it will fall on that same graph. Okay, have this down and we're going to move on. All right, for exercise 1, you're going to be trying this out on your own a little bit. It says the number of devices a particular manufacturing company can produce is a function of the number of hours spent making the devices. So we have hours they spend, and this is the devices that they make. Okay, remember I said it's always nice to make a table to help you out to begin with. On average, 4 devices are produced each hour. Okay, assume they're produced at a constant rate. The first thing I want you to do is write an equation, okay, by finding your m, your constant rate, and then I want you to find these answers, okay. Tell me how many devices are produced in 8 hours, 6 hours, and 4 hours. Okay, go ahead and begin on this. All right, reviewing our answers now for part A, you should have found that your m, or your constant rate, was 4 divided by 1, which was 4. So the equation you should have come up with is y equals 4x. Okay? You should have used that equation for part B, C, and D to find your answers. For the first one, y equals 4 times 8. For the second one, y equals 4 times 6. And then this last one here, y equals 4 times 4. Our answers for all of these are the first one, 4 times 8 is 32 devices are produced in 8 hours. The second one, 4 times 6 is 24. So 24 devices are produced in 6 hours. And the last one, 16. 16 devices are produced in 4 hours. Let me know if you have any questions before we move to the next screen. All right, for this part, I want you to go ahead and graph the points or the values that you found with your equation as coordinate pairs. So you're going to graph 1, 4, 8, 32, 6, 24, and 4, 16. And you'll connect them and create a line. And then you're going to answer these questions. What shape does that graph take? And is it discrete? Okay, give you a couple minutes to do this. All right, our first function pair was over 1 up 4. So over 1 up 4. The second one was over 8 up 32. So over 8 up 32, right here. The next one was over 6 up 24. Over 6 up 24. And then this last one was over 4 up 16. Okay. When you connected these lines, you should have determined that it formed a straight line. The last thing we're asked to do here is determine if this was a discrete function. So remember that this function is about time and devices produced. So for our x value, which is time, could these be in partial increments? Could they be in decimals or fractions? Could you go 1.5 hours? Could you go 4 3/4 of an hour? Absolutely. So this is not discrete. We can have decimals and fractions. For our x. Okay, check your work with mine. Ask me any questions before we move on. All right, so what we are going to do here is for this first one, you're going to tell me how many devices are produced in 1.5 hours. So use your equation y equals 4x. And tell me how many devices are produced in 1.5 hours. Okay, and then if we were to write that answer as an ordered pair, do you think that it would fall on our line on the graph that we just made? Would it fall on the line? Answer that for me. And then do you think that every number we put into our input and output is going to fall on the line? Will they always fall on that line that we made? And then we're not going to do K. We're not going to actually try it out. So take a second to do this before we move on to the next screen. Answer those few questions. All right, for the first one, you should have got that y equals 6. So in 1.5 hours, 6 devices are made. So would this fall on the line? Absolutely. So if we had 1.5 for our x and 6 for our y, yes, it would fall on the line. And the reason this is true is because it follows the same rule. It follows that same constant of proportionality. Okay? If we plugged in any random number for this, if we put 36 here, and then we found that, would it fall on the line? If we put 212 or 202, would it fall in line? The answer is yes. Any values that follow the rule will be on the line. Okay? They will all follow that same line if they follow the same rule. Okay? Let's go ahead and move on to the next one. All right, these last ones right here, we are going to answer a question about these last 3 graphs. It says, examine the 3 graphs below, which, if any, could represent the graph of a function. Explain why or why not for each graph. Okay, so this first graph, let's look at it. I have these points here. I'm just connecting them. Do you think that is a function? Write your own response. The next graph, I have these points right here. Okay, Okay, do you think that's a function? Explain why or why not. And then this last one. So look at those 3 different lines and explain why or why not those are functions in your opinion. And then we'll go over the answers really soon. All right, for this first graph, what I'm going to do is I'm just going to write down these numbers, and then I'm going to see if there's a relationship. So the first point right here is at -2, 4. My second point right here is at +2, 2. The next one is at +4, 1. This one is at 6, 0. And then this last one is at over 8, down 1. Okay, so these are my values. And I want to determine if this is a function. So remember that a function means that each input has one output. So this x, this -2 only has a 4. This +2 only has a 2. This 4 only has a 1. This 6 only has a 0. This 8 only has a -1. So yes, this is a function. Each input has only one output. Okay? Let me know if you have any questions there. We're going to move to the second graph. All right, for the second graph, I'm going to write down my points. This one is at 0, 0. This one is at over 2, up 3. This one's over 4, up 5. This one is over 6, up 6. This one is over 6, up 4. This one is over 7, up 2. And this one is over 9, up 1. So those are the points I have here, and I'm going to see if this is a function or not. All right. My input has only one output of 0. Okay. My input of 2 only gives me a 3. Input of 4 only gives me a 5. Input of 6 gives me a 6. Input of 6 gives me a 4. This is where I have some trouble. Okay. I have one input. 6 is giving me 2 outputs, right? I'm giving a 6 in, and I'm getting a 6 and a 4 out. So this is not a function. And the reason is 6 has an output of 6 and 4. Okay? Whenever you have 2 x values, guys, you're going to have not a function being graphed. All right? Moving on to the third graph here, graph number 3. I have a point at -3, -9. This one's at -2, -4. This one's at -1, -1. This one's at 0, 0. +1, +1. Over 2, -4. And over 3, -9. Now instead of going through each and every single row here, I'm just going to look and see, are any of my x values repeated? -3, -2, -1, 0, 1, 2, 3. Nope, none of those are repeated, so yes, this is a function. Okay, let me know if you have any questions before we move into our exit ticket for today. Our lesson summary today is that the graph of a function is just defined to be a set of points with an input as your x and a y as its output. A function can be described by an equation, and then the graph is the same as long as it follows that equation. Okay, no matter what points we put in, it's going to follow that same line, that same pattern. It is not possible for 2 different points of the graph of a function to have the same x coordinate. That is not a function. Remember, we can only have one input for each output, right? So our x, if there's two x's with different outputs, say this one is a 2 and this one's a 4, then this is not a function. Okay, moving on to our exit ticket. All right, here is your exit ticket for today. Please make sure you're doing it in Galileo. I'm going to go over it on our Galileo page instead of right here. So watch me switch over to that, and then you do your reflection afterward.